Okay. Hi, everybody. Welcome to the Istio Networking Workgroup Community Meeting. Today, we will try to do a few things. First of all, get some resolution on the ServiceEntry discussion we had last week. There is a document, there have been comments. So John will give us a short overview of the situation and also discuss the open items. Next, there'll be quality load balancing. So I'm not sure who added this, but hopefully.
Sorry, that was me. I forgot to put my name.
That's you also. Okay, John. So sure, we'll discuss about that as well. And then Andrew will talk about the Envoy listener split and some issues related to that. We have quite a few items on the agenda. Okay, and there is a proposal I see. NF tables as a better alternative to IPTables. Again, not sure who added this. Please add your names. It makes it easier to hand over. So since we have about like 4 items, let's try to do like 10 to 15 minutes for each of them. Is that okay?
Sounds good. We can bump the locality one to the end as well.
Okay, good.
Yeah, so for the ServiceEntry resolution, quick summary for those who haven't read the doc or forgot about it. Basically, the problem is with Kubernetes, host names are unique across namespace because the namespace is part of the host name. So you'd have like foo.default.service cluster local, whatever. But with service entries, you can define a host name like google.com, and it's scoped to a namespace that the service entry was created in. And so this opens up the problem of having multiple, the same host name rather.
Sorry to interrupt. You have to qualify external services.
Yes,
external services, you have to scope it. For internal services, once again, you have the same problem.
Right. So two namespaces to define a google.com, and all of pilot code is mostly keyed off of host name. So we assume that host names are unique. And this runs into all sorts of problems. For example, telemetry, it has the source namespace. It will just pick an arbitrary namespace that has that host name in it. There's other ones where they get like the instances of a service, and it will pull from all of the namespaces, which is usually not what people want. So this opens up the opportunity for, say, some team has created a google.com service entry because they want access to that service. And now another team creates another google.com and is now interfering with the other team. And in general, we would resolve this with the sidecar and do scoping, but this doesn't actually work for the overlapping host name because how I mentioned that we're keying off host name and pilot internally. So this document is basically designing a new way to handle this situation. And essentially, any particular pod will only be able to see a host name in a single namespace. And so if you had google.com defined in namespace A and namespace B, you could have pods that see the google.com in A and pods that see the google.com in B, but you would never have a pod that will either arbitrarily choose between one of them or get both instances of those. And which one it gets is determined by the sidecar scope.
Is that only when the sidecar scope is enabled? Because I don't believe we enable it by default in 1.2.
This would be even without the sidecar enabled.
Then how would this work for the other configuration which are global? Why are we making this unique?
What do you mean by the other configurations which are global?
So there is this global sidecar configuration file you have to apply to enable isolation at the namespace level.
Right.
So if you don't apply, which is the default behavior in 1.2, I was under the impression, which could be wrong, is your virtual services would be global.
So
I know the other configuration, at least network related, I think are global.
But what would happen if you define the virtual service for the same host in two different namespaces? I don't believe we do merging of the virtual services.
We currently do merging.
Only on the gateways, not for sidecars, I thought.
Yeah, only on the gateway, which I think we do merging at the gateway.
Gateways,
you could have different passes for the same host.
Yeah, so the problem though is the virtual service is just defining the actual routing. And so the virtual service has a namespace, but the namespace is not really exposed in the actual Envoy config, right? With the service entries, it's different. We have telemetry uses the namespace. The clusters, endpoints, it's a like if you have this conflicting namespace. So for some more context, the original issue
Right. I think
was
what he's saying is that, or like today, if you have virtual services, destination rules, and so on, and if you use a sidecar config, then it will only import from the namespaces that you actually specify. And if you don't specify a namespace, then the conflict resolution is undefined in some sense for virtual services. Basically, we just say like some things might crash, and we don't actually give a guarantee. And for destination rules, we have a certain specific pattern that we use to resolve.
right.
But for service entries, for external services alone, and that's why I'm scoping it, for service entries, traditionally we've only said you can only have one service entry for that specific postman for the entire mesh, whether it's external or internal. And what a few of these customers wanted is that, like, we want, just like the way we can specify destination rules private to a namespace or virtual services that are private to a namespace, we would like to specify service entries that are private to a namespace where only that sidecar can actually use it, and it will not get, it will not get messed up by service entries declared in other namespaces.
Yeah.
So
Strictly consumer point.
that does mean then the virtual service is still a problem where the conflicts are not handled, right?
Yes, but that has always been the case, right? We've always said that we will not do merging for virtual services from different namespaces for a sidecar. So you have to use a sidecar CRD to import the right virtual service and make sure you only import one. If you import multiple, then it's just going to be undefined behavior. So I would say, however, that we just simply stick with the same behavior as virtual service for consistency, and we simply say like, use a sidecar CRD to import a single service entry. If you import multiple, we'll just leave the behavior to be undefined, which rather than having a specific resolution behavior. And we also scope it down to the point of saying that this whole service entry, multiple service entries thing, we can only guarantee correct working for external services. If you do it for internal services, a bunch of things can actually go wrong. The type mesh external, mesh internal. If you do it only for mesh external, then yes, sure. But if you do it for mesh internal, then things will just not work correctly. If you scope it that way, then it probably becomes a more tractable problem where people can specify alternate targets for google.com or whatever it is, their internal services, and then they can play around, test with it, and it still give the same properties as virtual service, as destination tool, and so on. And then a simple example is, if you, like, even at IBM, if you're just talking to, like, let's say, the logging service, or if you're talking to a DB service, and if somebody is playing with their application a specific namespace, and they don't actually want to go talk to the entire logging service, but they have a mock version of the logging service declared and specified and running in a simple mock application, a mock service in that namespace, right? They don't want to modify their existing, let's say, big Java code base, which is actually designed to directly call that logging service, right? But when they can add a local service entry, effectively like a proxy, that says when a call goes to this logging service, please route to this, local dummy option for my own personal messaging and so on and so forth. So there is a definite development level, like, utility to that people can actually declare. For example, if they go to staging environment and they still want to point to a local staging version of a particular thing, and but then they want to take the exact same unmodified code and deploy it in production and let it actually call the actual DNS name that's specified inside that code, then it actually becomes this facility would actually be very helpful. It's pretty much what virtual services help you to do today.
So I think it's good to have consistency. If I understand, Sharon, what you're saying, I think we might be thinking same thing. So I'm thinking if I enable my global sidecar, then so let's say for 1.2 for the default behavior, which is everything is globally, all the configuration are pushed. So in that case, if I have maybe multiple services in different namespace that needs to refer to the same login service or Google services, then if it's the same, no problem. If it's different, and then you would have to enable the sidecar configuration, essentially.
Sidecar is required if you want security. So in fact, it seems we cannot solve this problem in a secure way without sidecar. So even if by default we don't require it, for serious like production users, it will become required.
One of the main drivers for this is we have users that have really big clusters where teams are separated at the namespace boundary, and there's basically a zero trust situation where one namespace, assuming it's not imported with the sidecar resource, should not be able to impact other namespaces. And today this is almost true, except for this case. And there may be some small other cases, but this is the main one that I'm aware of, that they can kind of hijack your host name and redirect your traffic somewhere else with the ServiceEntry.
So John, this has been the problem with the Istio networking config for almost all resources if you don't define sidecar. And
yes.
it looks like then for service entries, you want to make an exception that it should work by default, even if you don't have sidecar scope.
No, he's saying that if you have sidecar scope, then it should work just like everything else. Today, it does not work like that.
I see.
Yeah.
So then that feels like just a miss in the sidecar scope functionality that we never implemented for me.
Yes,
Right, and I think that's okay. I'm with Neeraj. I actually misunderstood you, John, at the beginning. I thought you meant you want to make an exception for service entry. So even without global sidecar scope, you want to do something special for service entry, which I had a little bit hard time because I think it's very hard to explain to user.
Well, I think it's not something special. We are changing the behavior from today to picking one namespace.
What I'm saying is leave it as undefined for the case where there is no sidecar. Let it be like, let people, let things go like wild, just like what we do for virtual service, destination routes, so on. But when a sidecar is defined, we provide the proper isolation. I mean, the isolation as like, if you define a sidecar, you import a namespace, only that namespace of service entry will definition will be imported, and nobody else's service entry definition. So that's the import name.
If you have a sidecar with */*, then shouldn't it behave the same as no sidecar?
Yes. That's the. I mean, because */* makes no sense when you define a sidecar, and that's that I'm just.
And I would add, if we are changing the default behavior when we have no sidecar, we should make it consistent across the board.
Right,
and not just have a resolution logic for service entries, because I appreciate the effort, John, that you're trying to make it simple, but as a user, I will have two different cases that I will have to think about, right?
Yeah, that's why I'm saying that, like, keep it same as undefined behavior for virtual services and service entries, just like today. And when you have a sidecar, let's make sure that this bug is fixed in some way, which is that when you import a service entry from one namespace, you only import that service entry. In other words, that service entry's endpoints, and nobody else can interfere by declaring a similar service entry somewhere else.
But will the default installation contain the sidecar or not?
We don't have it. We have not enabled it today, the default installation. Because the reason is because Helm does not allow you to create that global config namespace. The Istio config, it only allows you to create only one single namespace, which is Istio system. But we need the sidecar CRD to be in a special config root namespace called Istio config, which is where we would specify the default sidecar thing. And Helm doesn't let you do the two namespace thing. But if you manage, I don't know why, but it's you cannot touch two namespaces in a single Helm chart. So, but if you manage to fix that by actually making it default, or like actually having the sidecar option be present always, then things will be much better.
Once we move to the new installer, we might be able to do that, right?
Right, because you can
Yeah, it
apply
should be able to
multiple
support it.
namespace. Yeah.
Same with
Well,
the
the thing
operator.
is, yeah, the thing is, user can turn it on. I mean, we provide this global default sidecar scope YAML. They can deploy it themselves.
Yeah, they can do that actually. Yes, and if they do that, then yes, then they have turn on the sidecar for everybody, and then people can go and override that sidecar in their namespace by declaring special stuff. And I would say, as part of the validation, we should probably add that we will just disallow */*, or if we just have */*, then we treat it as a standard case of no sidecar.
So it does push more configuration to the users, but as long as it is deterministic, it makes sense to me. Because you have to configure now sidecar on top of your virtual services and
No, but
ServiceEntry.
there's a global sidecar we can configure once for all namespaces, which
Yep.
is the default setting that says all namespaces depend on only themselves. And you can define that global sidecar, and then nobody else has to write it again and again.
So the
we-
global sidecar is the one that basically isolates namespaces, right?
Yep, if enabled.
Yeah. If you download the release binary, it's in the install Kubernetes folder. Yeah, so I think I'm agree with Shira and Niraj. It's important to have consistent behavior that we can explain to our user consistently. I think that's more important.
Yeah. So John, do you agree with what's being discussed, or is that in sync with your proposal, or?
Yeah, I think that makes sense. I mean, today, if you have multiple host names and different namespaces, it's pretty much undefined. And if we keep it that way for no sidecar, that's fine with me, as long as it works when you do have the sidecar.
Yeah, because it seems we cannot like solve the problem deterministically for the.
Right. It doesn't. There's no real. I don't know how you could solve it without the sidecar.
And as long as we target a solution where this sidecar will be configured by default during the installation, then they won't need to do additional configs, right? If we can like.
This doesn't.
Yes, we will ask that, but once the new installer is ready, that's going to be in 1.3, or it is already ready, but not everybody uses it.
We could actually change our documentation to say, like, the first step that towards Istio installed is to enable the sidecar resource and actively educate people that they should explicitly declare dependencies on other namespaces, so that, like, by default, you only get namespace local access only, and then you can explicitly add other namespaces to your system to do X or Y, which would actually make it easy. Even though we don't mandate it as a default install, we can actually do so in all our documentation, because whoever is actually following it, the newer users, they will adapt to this thing, and that would just make it easier.
Yeah, this could be 1.2 if we have that doc. Yeah.
Okay. So then are we good with this first topic, John?
I think so, yeah.
Okay, great. Thank you. So we can move to the next one then. And we've done a great job in a very short time. So are you okay then to let Andrew talk about the Envoy listener? Because that seems to be very much related to like active work.
Yeah, sounds good.
Okay, Andrew, are you there? Can you please take over?
Yeah. Hi. So this is kind of circling back on an issue which is related. So the issue is basically when a pod tries to talk to its own pod IP, which happens for some some services, like especially Kafka is an example of this. A Kafka cluster, there's a leader that will talk to a bunch of other nodes, and it will also talk to itself via its own external IP. And so the problem in the existing versions of Istio is that when it tries to talk to itself, it only goes through the inbound listener in Envoy, not both the outbound and inbound listeners, or neither. If it goes through only the inbound listener and you have, require MTLS turned on, it doesn't work. And so that's sort of the fundamental issue, this 12.551. And so there's kind of two ways to fix it. One is if you talk to yourself, you get to short circuit all Istio policy, telemetry, everything. If you talk to yourself on your external IP, the other option would be to go through both listeners.
One question is, why is inbound being intercepted at all? Though, because if a pod tries to talk to its own like IP address, does the call go out of the pod network namespace and then come back in? Shouldn't the IP, we have the IP table rule that says that, oh, I guess it's only for loopback traffic. Is not
yeah, it's only for the loopback.
Yep. So literally 127.0.0.1 skips all of this and talks to itself. If you talk to your own pod IP, you go through the IP tables, you get to Envoy, but you only go through one of the listeners. That's what the breakage is. So you can fix it either way. We talked about it a couple months ago and didn't really decide on what way we wanted to fix it. But this PR 13666, it looked to me like the beginning of stuff in IP tables to split so that Envoy could correctly differentiate inbound traffic from outbound traffic. So if it's an outbound connection to its own IP, it could potentially run it through both listeners. But the thing is that while it does the IP table stuff, it didn't look to me like it did the Envoy side of things. But I don't know if that's actually the goal or not.
Can you distinguish IP tables? Because if we had the ability to distinguish the target IP address, like the pod zone IP address in the IP tables, then we could have done it even with a single virtual listener, but I don't think we have that ability. So,
say that again, Sriram.
So to Tim's point, right? Like we have this whatever the like gate inside the IP tables thing that says all traffic for loopback address will just be like ignored, no capture and no Envoy.
Yep.
But we don't have a thingy that the rule that says all traffic to this pod's IP address, the specific A.B.C.D IP address should not be captured from within the pod. And the reason is because we don't know that IP address a priori. Maybe we could do some parameterization and know that address a priori, in which case when a Kafka pod calls itself, that traffic will probably just not get intercepted. Oh, so it still goes out of the.
We don't want this. So when you refer to your local host, yes, you can bypass. But when you refer to your pod IP, you still want to go through the outbound and then inbound to get all the telemetry and all the things, right? Because you may want to be able to have metrics on the calls you made to yourself as well, right? And I think this listener split will definitely help, right? But I'm not sure if anybody has in plan to test this exact test case, because there might be like a few other tweaks needed.
The question is, if the pod calls itself, does the call get out of the pod's network namespace and come back in as an external call, or does it just loop within the network namespace itself?
I think it just loops within the network namespace of the pod, but it does go through all the IP tables rules that we add.
That we can fix. If it's as long as it's looping within the network namespace of the pod, then there's a way in Envoy to fix that. There's a filter chain matching condition that says that if the traffic is originating from the local IP address, then or if the traffic is originating from a remote IP address, there is a matching condition in Envoy, and we can actually augment the PR that Yuchen had by adding this matching condition such that it would satisfy your use case where when a pod calls itself using its IP address, we can ensure that it does not go through the MTLS thing. It will go directly, it will just be a pass-through in that sense.
Sriram, I think you're saying explicitly that we want it to go through the Envoy filters so that we get telemetry.
We will just not go through MTLS filter. Today we have a filter chain match, which basically says for all traffic that's entering the pod, subjected to MTLS with some sniffing and all the other stuff. But we can actually add a second match condition that says for all traffic that's entering the pod, and if this traffic is coming from an external IP address, then subjected to a MTLS. But if it's coming from an internal, basically local IP address itself, then skip the MTLS and go directly. Skip the MTLS and do the rest of the listener stuff.
I think that is compatible with this use case for sure. If I think about it as from a outside user perspective, what I want to feel like is it's as if it went through the outbound and then the inbound for all policy. Now, if internally you can short circuit it by not actually doing MTLS, that's cool with me. But from like the perspective of all policy, virtual services, telemetry, everything, I want it to feel like
you will have
the same thing as if it connected to a different
policy. You will have all the other stuff, but I think this works if and only if that traffic loops within the same network namespace. Because the moment that traffic goes out of the network namespace and then comes back into Envoy, I think it loses the ability to distinguish where at that point it would treat that request as though it's coming from an external source.
Well, so that would be great too. If I applied the outbound policy on the way out the door, then it went out and came back in, that's fine with me too. Like, there's overhead there, but that looks exactly like connecting to any of the other pods.
Exactly. I think that overhead is preferable. I don't think we should be bypassing MTLS at all.
I agree.
Like going out the door, coming back in or something.
He has a problem that says this, like if the pod calls itself and the pod has MTLS, then the thing breaks. That is his problem. That he has the Kafka problem is that when Kafka calls itself using his IP address, and that call comes back into Envoy and Envoy expects MTLS, the whole Kafka thing breaks because it should not be subject to MTLS because I'm just me calling myself using my IP address.
Right, but it should be able to encrypt and decrypt, right?
It should be all right for the connection, the outbound connection to go to Envoy, then Envoy to talk to itself, even if that leaves the network namespace and comes back in.
That piece, I think that's the piece that we're actually actively avoiding in the IP table because it causes those loops within Envoy. So it would not talk to itself. I don't.
But now that we have the split where we can differentiate outbound from inbound, I think we have an option to fix the looping. You do pay the cost of actually doing the outbound and the inbound. I think that's preferable from a consistency perspective.
That's true. Yeah. That would definitely work. Yes.
But really, as long as as an end user, I feel like that's what I'm getting. I don't care if there's internal optimizations.
So, Andrew, I had a look at the issue you are pointing to, headless services, pod phase, and TLS handshake with itself. So if we want to solve this, we should have an issue that's less related to headless services, right? Because it's related to the, a pod talking to itself. So maybe you want to open a more general issue and decouple it from the whole headless so people can add tests specific to the issue as opposed to trying to get this to work with headless. You'll be in charge with getting this to work with headless.
That's fine. I think, Yuchen, this is kind of where, is this the direction that the listener split is going on its own, or is this a change, is kind of my question.
So that's Yuchen. I saw him with John. Yuchen.
Yeah, he's here.
I didn't think the split is supposed to solve this, but we can, I think.
Yeah, we can do it as a separate, right? It doesn't have
the initial
first deliverable for that, but as a in the roadmap for the next.
Then it sounds like I am going to open an issue to explore how we should implement what happens when any pod tries to talk to its own external pod IP address. And I'll talk about what we talked about here, and people can chime in if they have different ideas.
By the way, when you say the IP, you mean the external IP? That's the pod IP or the service IP or
IP?
So this is why it's especially important for headless services. It is, in this case, the pod IP.
Okay, cool. Thank you.
So a side note is that the inbound listener split needs to be a global configuration. Today, it's actually a per pod configuration through an arbitrary environment variable, and there's no consistency with the fact that in a global configuration, we actually have the proxy listener port as a configurable field in the mesh global configuration. Maintain that consistency, we should have a similar global configuration that says proxy inbound listener port so that people can actually enable it throughout the mesh. and not have to go and instrument each and every sidecar to add this additional environment variable. That would just not be a scalable approach. So, and we decided to like add things to the mesh global thing because we are going to move the new installer. So let's add it to that and remove that as from the sidecar level thing, because it's just not consistent and it's also very hard to use.
Yeah, I think when it's become mature, for example, in 1.3, it should be a global mesh config.
If this becomes a mainstream use case for Kafka and kind of things, then it has to be a global config. You cannot have a one-off thing because the default Istio installation will immediately break for headless services. Then it's not nice to then go and make people come and file an issue, and then we tell people that please add this obscure environment variable to that Kafka pod, and then they go out and it fixes it. That is not a nice user experience. From a user experience point of view, it should just work out of the box. And in order for us to be able to detect and do the thing, if this is enabled as a proper global configuration, then it actually makes it much easier, especially in the context of headless services and other things. This should just be that's the reason it's not wait for 1.3 and so on, but rather introduce it now. 1.2, this was introduced in 1.2, so by the next release or the past release, we should have that as a global configuration.
Okay, if that's a requirement, sure.
Is there an overhead of splitting? I just want to understand. I totally agree it should be by default so that everyone does not have to enable it on case-by-case basis. But is there actually some overhead from Envoy's perspective?
Actually, no. Just like an before. I mean, it's two listeners instead of one listener, but that's just not an overhead. It's two virtual listeners instead of one virtual listener. That's all. So it's not an overhead. And it has other security properties as well, which is that you can just prevent somebody from bouncing via Envoy to a different IP, because you can just guard the outbound, and you can set up the IP table rule such that the outbound proxy listener port will only capture traffic for outbound traffic and not inbound traffic. Similarly, you can again set up the IP table rule such that the rules for inbound will only capture things for the inbound traffic and not the outbound traffic. The IP table setup will actually become much more clearer and cleaner because we now have two separate ports, and we don't have to do. Today, we're actually doing some lot of crazy things to detect mark traffic back and forth and do things over and over. And we would not have to do any of that stuff because a lot of things will go away because we now have two clear, distinct ports to capture inbound and outbound. Tracing will also become simpler because we can now actually clearly identify what traffic is inbound, what traffic is outbound, and we can automatically tag that traffic. So there's a whole bunch of benefits that come with it. with the addition of an extra listener in Envoy, which is not that much, an extra virtual listener in Envoy.
But that extra listener does not affect the performance of forwarding the traffic. In fact, it might even be better. So depending on how they do the lookup, right? You might have fewer things to look up through because you're already like inside the listener with fewer configs.
Yeah.
And
sounds good.
All the other stuff that it's just so much simpler to understand it from the IP tables rules. I really like the split already so far.
Yep, agreed.
And I want to add one thing. So there was this mention of going to the pod IP and the headless services. However, if I have a service and I have a single pod, I'm the one implementing that service, and I talk to the service, I should be able to have that traffic sent back to me with the same approach, right? So
yes, but because you are talking to the service IP, you skip, you dodge this issue just a little bit. But the way to solve it forever and never have to come back is to do the inbound-outbound split.
No, I'm just saying that the inbound and outbound split and this should work the same, even if I'm talking to a service and I'm the only pod in that service and I'm talking to myself, right? Because there was this question, should this work just for the pod IPs or for services? Yeah, it will work the same for services.
Yeah, I think the service IPs currently work as far as I know. You don't have to do anything for it.
Okay, good then. All right. So can then we move to the next topic?
Yep.
Good, thanks. So the next topic, let's see. We have a proposal NF table is a better alternative to IP tables. Or like we should do the locality load balancing. So is that, John?
We can do this NF tables one.
Sorry?
We can do the NF tables one.
Okay, good. Stephen, are you there?
Yeah.
Okay.
All right. So you probably saw some email discussion in the context of distroless that there was an attempt to replace current IP tables implementation in init container with a Golang equivalent. And well, there was a solution provided, and I mean, in general, it would work. But there are some disadvantages of current approach. Basically, what was done is they replaced shell IP tables call with the equivalent of Golang OS execute commands. So I mean, it's better, but I mean, it's not ideal. Another disadvantage is that the way it's proposed is that it cannot be shared. Let's say it could work in an init container context, but let's say it won't be usable for Istio CNI because they packaged it as an external binary. So based on that, team, John and myself, we had some discussions, and we were trying to come up with the library approach. So basically, the library which can be shared by Istio, init container, Istio CNI, and etc. We checked available libraries, and there was no good library for IP tables. All of them use the same approach. They wrap binary and call it. So pretty much the same thing. But in the newer version of the kernel, there is a by default support for net filter tables. It provides equivalent functionality.
How new? What's the kernel version you're talking about?
I think it's from 3.18. So it doesn't require like a crazy 5.0 or something like that. So I mean, like I'm running Ubuntu or Disco, and it's there. I mean, it's version 5, but it exists in a different.
So Sergey, sorry, you said you for the same support. Do you support tproxy as well?
Well, that's the weak point. I mean, there is
that's a non-starter, because without tproxy we won't be able to do UDP.
No, tproxy is supported, but it's not packaged in the latest package available. So the next official release will have a support for tproxy.
You mean it's a kernel problem or it's a user space library problem?
It's a kernel problem. I mean, that's what I read. I mean, I checked the tproxy availability on the NFT, and they say it is. I mean, you can have it if you use a pre-release kind of a version. So
what kernel version are we talking about? 5 dot something?
Let me find out exactly the version, and I'll share it. All right.
Because we want at some point, maybe in 1.3, to make tproxy a Z mechanism in Istio CNI.
Yeah, and
so we can actually use it.
Sorry, the mic was broken. I had to run over. So I'm sorry. So if we switch to NF tables, in order to get tproxy working with UDP, does that effectively increase the minimum kernel version that we depend on?
As long as this kernel does support it.
Okay.
Yeah. Well, I mean, it's supposed to. As I said, the people are aware, and they said it should come out soon.
But that increases the minimum kernel version.
I will have to check whether I would have to check.
Let's slow down on. So there's an effort. People want to put an effort to rewrite this into Golang. I think what we can do is have a multi-option approach. So if for the tproxy problem, we could potentially still leave the wrapping of IPTables client calls in there. Just have a Golang interface that supports both methods. So for those that want to have the full distroless NF tables approach, we wouldn't be able to support the tproxy right away, so that would be a problem. But the current non-UDP functionality would work, right? So I think this is what we're thinking, a library approach, unless somebody wants to write an IPTables library.
I mean, we are pitting T-proxy and UDP redirection versus distroless. Which one is more important?
But do you think that we need to make the call on that? Right. I think we could implement both of them.
Well, but that's two things we have to support.
It's two images.
There's two things we have to support. So I think the preference should be one.
So there is a version of IPTables which does the translation to NF tables. We found out about this the hard way because within the OpenShift distribution, they recently changed to having NF tables on the host, and the RHEL 8 version of IPTables does the mapping. So we hit issues with that specifically because we had some hosts which were running either on RHEL 7 or were running on older versions of OpenShift which would not support or were not natively running NF tables, so none of that would work. We ended up shipping 2 init containers, and at the moment we have people choosing which one they want, but the plan for our next release is to actually run both of them. The CNI plugin that we have, which is based on Multis, that works around that because that relies on the IPTables that's on the host system. So if you have the NF tables variant, it will translate to NF tables straight away. So they're likely
performance. I've had some guys complaining to me this week about Knative performance. They say Istio Nets take 6 seconds to run. Do we have any idea if that would be solved by any of these proposals?
I've never seen.
It's hard to say, but I mean, there was some tests done in the past, and NFT tables were way more performant than the IP tables, and using them so I mean, but it's hard to say whether the Knative has anything to do with the way that they use IP tables or not.
Knative doesn't do anything other than use the standard Istio init.
Right.
They want a fast start, so they want a very quick pod start. And when I was told it takes 6 seconds to make Istio init run, I was surprised. It seemed high.
Istio CNI should suppress that.
I mean, but the 6 seconds could be tied to the amount of time it takes to OS exec all those IPTables calls. I mean, that's a classic IPTables problem, right? It's rewriting that table every single call.
Yeah, that sucks.
That's the advantage of NF tables.
Yeah.
We have almost no rules. We have almost nothing in those tables.
How many IPTables rules do we have?
Almost nothing. It's like a dozen rules.
A dozen?
Right. Well, anyway, so we're working on the table on the library, which is leveraging Google NF tables library with a very low level primitive. So we're trying to build a little bit higher level of abstraction, which would be similar to currently used with the IP tables. And when it's ready, I mean, we'll show the use case and how it works. So just more like a heads up to the community.
Okay.
So yeah, can you do a prototype and maybe give us some numbers? I think if you have numbers, that would be very convincing for the switch.
And NF tables is definitely more performant. That's the main reason that OpenShift switched to NF tables instead of IP tables.
Okay.
So it's much faster.
Kevin, how many IP tables rules were there?
Well, this is OpenShift itself and the kernel, so it's everything that they're doing on their side. It's not specifically to do with Istio or what we are doing in the init container.
Okay, and I think I just saw a chat go by. Somebody tried this and they thought it was 0.8
Yeah, there's
seconds.
a lot of. I timed it just on a small cluster. It's probably on a larger cluster, or maybe with the image full time, it takes 6 seconds. But that's certainly not. It doesn't always take that long.
So it increases image full time.
Yeah. So
I think IP tables performance is impacted more with what else is going on.
Right.
So it may not necessarily be the init proxy, the init container itself, which is taking the time. It could be other things which are going on within IP tables as well. whereas NFTables doesn't seem to suffer from the same issues. So it handles the concurrency a lot better.
So I think to summarize, as Sergey said, we were looking at it from the NFTable standpoint, but it's in the context of overall rewriting that Istio IPTables in Go. We think the design of that could be made so that we can option the approach with a single image. So you configure a single binary. You may package it in multiple containers for a NIC container, but we should be able to do this.
I'm just trying to think through the whole thing. So if we replaced IPTables with NFTables, we would lose T-proxy support for UDP. Anything, right?
Correct.
If we only support that right now.
We only support NFTables, yeah, but
and we don't use T-proxy for UDP. Envoy does not support UDP.
Okay.
Not yet. Quick is coming, but would we actually would inbound connections to Envoy actually be UDP? Would they continue to be TCP, and we would just have UDP to do the sidecars? Does it need to be transparent?
You need to do load balancing. Like you have you have cluster IPs for UDP traffic too. I mean.
So hopefully by the time you guys need the UDP support, the T-proxy for NFT will be available as well.
Yeah, but the minimum kernel version would still be a problem, right?
Right, but as Tim mentioned, I mean, we can basically, we should support like two mechanism drivers, like one driver IPTables for the older version of the kernel, and one driver for newer kernels, NFT.
Okay. So we would have more maintenance costs because we have to maintain both, but on newer kernels, the pods would start faster.
Yeah, exactly. The big advantage.
So the kernel, is that the host of the kernel, the Kubernetes worker nodes?
Yes.
Okay.
Yeah, it's the host side of the masters of nodes. Yeah. The IPTables approach, so we're doing what has just been suggested. We're actually deploying two init containers. We've got one which is based on IPTables, and we've got one which does the IPTables translations to NFTables. So when it's running on an NFTables enabled host, it can take advantage of that. So if we can come up with something, especially if it's a single deployment, single binary, which handles both, then that's the ideal situation.
So maybe the next steps are get some numbers on this and decide whether it's worth the added maintenance costs.
Right.
Well, I mean, the initial motivation was to do distroless, right? Is it distroless or is it performance?
I don't know. Good call.
Well, the trigger was distroless. You're right. Because the way how they propose to use the IPTables and the Go is not efficient, it's not convenient. I mean, the only advantage is that it can be tested. That's all. With the NFT, we have a better packaging and performance. So we have two gains instead of one.
Okay, I think we have action items. Can we move on? It's like somebody commented they want to discuss something else. So.
Sorry, I was muted. All right, thank you. So in fact, there was an item that somehow got deleted from the agenda, and there is some discussion related to extensible filters and the Mirage and Shriram think they can solve it quickly in this meeting. So which one of you wants to start, Shriram?
Sure, I can give an overview. I don't know though what the issue is. I think we had the Envoy filter for quite a while, and there's been a lot of users of it. Unfortunately, that has shielded like a whole bunch of add this to Envoy, add this to Istio, add that to Istio in the API. been able to keep the API low, and at the same time people have enabled their custom filters. And so I've added some improvements to the Envoy filter that would actually enable people to not just add new filters, but they can add new settings. I mean, like change settings on the listener or the cluster and so on. Because, for example, we've had a whole bunch of requests to enable a specific HTTP2 option on the cluster, or a specific option on the HTTP connection manager for gateway, like X forwarded for settings, or this cookie setting, or like from the timeout setting and so on. And frankly, that is an API burden, because for every feature they add, we have to find a way to accommodate that in some API or the other. And then the API surface becomes bigger and bigger. And and we are trying to keep that API surface small in the interest of maintaining complexity low. So what we have done, and the idea behind the existing Envoy filter improvement here, is that we will actually provide a simple patch mechanism, such that after we generate all the config, you can specify a bunch of additional settings that you'd want, and we would apply your settings on the generated config, and we'll put that to Envoy. There is a very, very big caveat that we place on that thing, and the caveat there is that if you use the Envoy filter, it is a break class configuration, and we will not provide any form of improved support, nor do we guarantee that things would work. So it is completely up to the end user to make sure that the settings that they're changing is the right one, and that pilot is not going to be responsible, since they're actually directly editing the Envoy settings. This is the exact same guarantee that we had even before this PR, which is that if you add your custom filters and your Envoy crashes, then we're not responsible. In other words, we cannot take, there is no way for us to go and debug what you're doing, because, you've changed the configuration that pilot has generated.
So Sriram, that's exactly the problem I have with it. As a company and as people here in Aspen Mesh who are trying to support Istio, basically we are baking in more and more break glass features which are inherently unsupportable.
But then the alternative is to actually continuously expand the Istio API, which means it adds complexity that everybody has to suffer through.
Well, hang on. So other open source projects with an API surface also achieve the same functionality. You have a core functionality that that you're not going to extend, and then you can have extension mechanisms. But those extension mechanisms should be reasonably supported. The extension mechanisms that we are providing are just impossible to support, because dynamically at runtime, without having organizational controls, you have multiple filters which might be trying to patch the same thing, or they might be trying to update the same thing. That's my concern here.
Yeah, but you can definitely block the Envoy filter CRD completely, right? Because today, without this, we are actually looking at about 4 to 5 very big API changes landing on the gateway, on the virtual service, and so on. This is coming from so many different users, not just big companies like Salesforce, but actually smaller individual users who have actually been waiting for 2+ months to add features to the gateway, to add features to the cluster, to add features to this. And that is on everybody in the Istio community, especially us who are actually writing code and actually fixing issues on the Istio and managing this, not at the company level, but actually in the open source thing. And to us, this is more like, okay, here is a way by which we can actually enable you. And yes, this is break glass today, but over time we might actually figure out a way to actually support it in a more proper way. But till then, this will at least unblock other Istio adopters, that they can continue using this Istio without creating their own control planes, or without hacking it and going.
No, I mean, once you have this API, Istio just feels like a glorified template language for Envoy, where at some point
not everybody is going to use this. Only very, very few people who actually want to tweak the configuration are going to use it. So 99% of the population are actually going to be they're happy with whatever things that they get, and that's basically what we've had for the last 3 years, right? And there are customizations, and people have typically basically forked Istio, and they've just made their own thing, and then that becomes yet another service thing, and that works for large companies. But smaller users will typically suffer, and then they'd go code with different service mesh or something of that sort. And the point here is to why, or we end up starting to accept more features in API and gateways, which is not a fair thing for everybody else. So.
Well, so going
1 second, you're right. So are your concerns in general about these extensions, or in particularly in the incarnation of this PR, like
particularly in the incarnation of this PR, especially because previously Envoy filters were used to just add new filters and listeners change. Now this PR enables users to patch or modify Envoy configuration which was generated by Pilot.
Okay.
So for me, it starts to feel like there are 3 or 4 layers of transformations that can happen after actually Istio control plane is giving something. So the space of configuration that you have to look for a person to understand what is actually going to be delivered to Envoy is really large. So it's
right, but nobody forces you in particular to use this approach, right?
it's more around if you start enabling features, you can't just say don't use 10 of these features because they're inherently bad. So
you disable the entire CRD, right? Because today, if you're supporting Istio and somebody is enabling a custom unsupported filter, if even worse, somebody has a filter config that's completely crashing, then that is no different than somebody going and adding a special setting on the listener, which could potentially crash, right? And that has been our motto from so on, because people have done the Lua filters and like do it in the wrong way, it will crash Envoy completely. But people are okay with it, saying that I will make my way with it and do it, because they want the 95% of configuration that flows in from Pilot, and they just want to tweak 1 or 2 different things.
I don't see a problem specifically with the fact that via the extension you can patch or like modify the existing config, right? And if there are use cases that require that, I see no reason for saying, no to this behavior. To me, it also seems limiting to allow just the ability to add stuff. I just want full control, right?
I think that's a fair point. For me, the only issue that has been happening is so going forward, whenever we have to augment virtual services or gateways, because we haven't defined what our core APIs are, you can always say, okay, let's not augment our primary API, but use the Envoy filter patching mechanism.
That's not the case, right? Because our philosophy so far has been, if 10 people are actually using this additional filter to add a custom setting, or 10 people are adding a special metadata to every sidecar, for example, the same discussion as the inbound listener, then that has to become a global configuration, or that has to become a part of the core API. But as long as that number is like, few people who are just doing it here and there, then that is like supposed to be like, you just do it as a one-off thing. But the moment it actually becomes much more widespread and well used, then it should not be in the Envoy configuration, but we'll actually like have a proper setting on the API to do it. So the point here is that there were 3 users who wanted some X forward for setting, and one person wanted to change all the default paths for all the certificates that Pilot was configuring, and a whole bunch of things. And all of these things can actually be like, this is one person's requirement and there's another person's requirement, and all of these together will just add a load to the API where we have no data on like if the entire world is using it or only just one person. Whereas when we have a sequence of GitHub issues that says, I want this, I want this, I want this, then these people come and like, then we are always going to go and add new settings. This is how we've been adding settings to virtual service. Then critical mass of users have complained that I want to add headers to request responses and so on and so forth. We reworked it rather than telling people use the Lua filter to add headers or use the Lua filter to remove headers. We actually like, I personally went and changed the API to allow them to add request response headers, because that was helpful for multiple people, not just one person. So that has been the motto so far that we add, and that's how we add filters as well, right? If people have been like adding some special filter, everybody adds it, then it's pointless to allow it to be like a special thing that we just inducted into the entire system, and it should become a no touch configuration thing out of the box.
That's fair. No, I mean, I'm okay with it as long as there is a path forward where you just don't do everything through the Envoy filter.
I personally don't have that thing much motto. This is more like there are people who just want one-off, and when that one-off becomes the most common case, we will push it into the main configuration, absorb it, no matter what changes it requires. Because at that point, that's the right thing to do in terms of keeping the amount of like break glass to a minimum actually.
Okay, so I think that makes sense, Niraj. Do you agree?
Yes, it does, and I just wanted to get a consensus on that, so I'm good.
Okay,
Thank you.
good. Thank you. So we're all out of time. We will defer to next meeting the locality LB items item that John added, and I want to ask if we need the meeting on July the 4th or not.
No.
So do people need a meeting that is sooner than a month? That's the question, because the next one falls on July the 4th, and many people are on holiday in US. Do we need one in 3 weeks?
The most contentious one is the Louis proposal for extensions, to be honest. So if he's not there, then I'm okay with it.
Right. So I think he'll come in time for the next meeting. Hopefully, I can check with him. Yeah. So then it's we'll cancel the one on July the 4th and meet in 1 month from now. If there is anything coming up, please let me know and we'll have a one-off meeting. Okay.
If it's going to be a month, can we just talk about this locality one over Slack? I don't think we'll have much debate. But.
Yeah, over Slack, and especially
hey, Shriyam, sorry,
he left.
Oh, he did. All right. Go ahead,
okay, I want to say, John, like we tried to discuss over a design doc or over discuss IO, because Slack goes away after a few days now. With all the messages being posted, there is no history.
Wow. Yeah, if we do it over Discussa, there's not going to be any conversation.
Okay.
Like we can paste it on there, but I'm just concerned like Slack is so much more fluid, you know.
Right, like if you like, I think that's probably okay, right? If you feel like you get what the input that you want from Slack, get it from Slack, but then write a design doc.
I'll copy and paste it.
Well, there is a design doc, so maybe just add an appendix section with the Slack chat, so we have it.
Yeah, exactly, and you can also like try to write those ADR, architectural decision records, where it's like that. These are short documents to explain the context, the problems, pros and cons, and the decision.
Sounds good.
Okay. All right, then. Thank you for agreeing.
Thank you.
Thank you. Bye.
Bye.
Thank you.
Bye.
Thank you.